welcome to Virtual Protocol Podcast. Right now, over a third of the new internet isn't written by humans.
Yeah, it's kind of wild to think about.
It really is, and your computer operating system is quietly learning to watch your screen to, anticipate your next move.
Right.
And on top of all that, a machine learning algorithm just played a critical role in developing a cancer vaccine.
Which is huge. And it paints a completely different picture than the standard narrative we're all hearing.
Yeah,
Because the prevailing conversation out there right now is incredibly binary. It's either, AI is this unstoppable force coming for everyone's job, or
it's just a massive tech bubble that's hallucinating its way to nowhere.
Exactly.
Which really leaves out the actual nuance of what the technology is doing on a daily basis. So I want to warmly welcome our listener, the learner, to today's deep dive. We are looking past the noise and the hype today.
Oh, we really are.
We've got a massive stack of source material, a really comprehensive, rapid-fire roundup of the latest AI news, courtesy of Matt Wolf's recent updates. And our mission today is simple. We are uncovering a huge fundamental shift. AI is no longer just this abstract brain floating in a corporate server farm. It is moving into our local devices, into our physical bodies, and directly into our personal, everyday habits. So, okay, let's unpack this.
Yeah, let's do it. Because the sources reveal some incredibly practical, tangible breakthroughs happening entirely under the radar.
Yeah.
Like, it's almost fashionable to be pessimistic about AI right now in the media, but this shift from the cloud to the physical world is undeniable.
It is. And let's start with something highly tangible, which is bringing virtual things into the physical world. There's this new model out called Tripo 2.0.
Oh, yeah.
And it generates 3D objects, but not just a flat 2D picture of a 3D object, right? It generates actual mesh files.
Which is the big difference here.
Right, files that you can export, send to a 3D printer, or drop directly into game engines like Unreal Engine or Blender. And they even give you 2 free generations on their free plan to test it out.
And the utility goes far beyond just getting a raw file. They've built in different rendering styles, allowing you to generate assets as like cartoons with heavy black outlines or sketch styles or even transparent holograms.
Yeah, but the style that really caught my eye is called unlit. Our source ran a highly specific prompt just to, test the limits.
Right.
They asked for a humanoid wolf with horns and wings, wearing torn jeans and a black t-shirt, flexing and standing on a tree branch.
A very specific request.
Super specific. And the AI completely nailed it. But the crazy part is, when you click the unlit style on that winged wolf, it actually removes the wing texture completely and leaves just the bones that were inside the wings.
Yeah, that blew my mind. Generating structural logic like that is a massive leap for game design.
Right.
You aren't just creating a static outer shell anymore. You're generating the underlying anatomy of a fictional creature.
Yeah.
So if you are building a video game, you could program the physics engine so that if the character's wings take damage, that underlying unlit bone structure is what's revealed to the player.
Which is incredible. But that structural logic completely falls apart when it has to match actual human reality, though.
Oh, yeah, the self-portrait.
Yes. Our source tried to generate a self-portrait from a photo of himself in a T-pose. It perfectly recreated his shirt, his pants, his shoes, even his skin tone from the neck down.
But the face?
The face was a complete disaster. It gave him these bizarre extra clown lips, mangled the nose, and literally generated human skin texture inside the lenses of his sunglasses.
Yeah.
He has like a brilliant sculptor who completely forgets what a human face looks like the moment you ask for a self-portrait.
That's a great way to put it. It illustrates the boundary of the current technology perfectly. It can hallucinate beautiful fictional biology, but strict replication of nuanced human anatomy still breaks it.
Yeah, it does. But speaking of human biology, the leap from generating fictional bones to saving actual human bodies is happening right now.
It really is.
We need to talk about mRNA 4157. This is a massive pivot from entertainment to survival.
And this is arguably the most significant piece of news in our stack of sources today. We're talking about an mRNA cancer vaccine that has shown definitive success in phase 3 trials for melanoma.
And what makes this trial impossible to ignore is the scale.
Yeah.
They had 11,137 patients involved. These are people with stage 2B to stage 4 melanoma that had already been surgically removed. And the clinical data shows this vaccine successfully extended the amount of time those patients had without the cancer returning.
What's fascinating here is how this story was framed by the media.
Oh, this part drove me crazy.
Right. Our sources highlight an article from Ars Technica covering this massive medical breakthrough, and the article doesn't mention the word AI a single time.
Not once.
As we mentioned, it's somewhat taboo to talk about AI positively right now, but Moderna's own website explicitly confirms how this works. They use fully integrated AI algorithms to review genetic mutations from a patient's tumor and blood samples.
Okay.
The algorithm then predicts up to 34 neoantigens that are most likely to elicit an immune response.
So let's break down that mechanism for the learner really quick. A neoantigen is essentially a flag on the surface of a cancer cell, right?
Right, exactly.
So the AI is scanning the genetic data to find the exact flags that will teach the patient's immune system what the cancer looks like. It's almost like printing 34 highly specific, wanted posters for the white blood cells to hunt down.
It's a perfect analogy.
But wait, I want to clarify something.
Yeah.
When we say AI in this context, are we saying some scientist logged into ChatGPT and typed, "Hey, write me a recipe for a melanoma vaccine"?
No, no, no. And that is a critical distinction to make. This is not a large language model predicting the next word in a sentence.
Right.
It is a predictive machine learning algorithm. It uses neural networks to process massive amounts of next-generation sequencing data to make highly educated biological predictions.
Wow.
It is pattern recognition on a microscopic, life-saving scale, learning over time through clinical data to become more accurate at selecting those wanted posters you mentioned.
That perfectly illustrates how AI is quietly mapping our physical biology. But let's look at how the power dynamic is shifting on our own desks.
Oh, this is a big one.
Yeah, because the control over these models is moving from massive data centers directly to our local hardware. Alibaba just released a new open-weight model called Qwen 3.827B.
Yeah, and we discussed their massive 2.4 trillion parameter model, Qwen 3.8 2.4T, recently.
Right, the huge one.
Yeah, and that model is powerful, but completely inaccessible for a normal user to run offline. But this new 27 billion parameter model hits a profound sweet spot. On the Artificial Analysis Intelligence Index, it scored a 52.
Yeah, putting a 52 in context, it ranks just below massive frontier models like GPT 5.6 Luna and Gemini 3.7 Flash, but it actually beats Anthropic's Opus 4.8.
Yeah, which is incredible.
And because it's open weight and smaller, you can run it entirely offline on consumer hardware.
Well, we do need to define consumer hardware here.
Fair point, yeah.
Because local AI requires significant memory. You aren't running this on a 5-year-old laptop. You need 24 to 32 gigabytes of VRAM.
Video RAM, right?
Yes, video RAM acts like the short-term memory or, the disk space needed to unfold a complex model. So you either need a Mac Studio with unified memory or a high-end NVIDIA GPU, specifically the 3090, 4090, or the upcoming 5090.
So the really beefy ones.
Exactly. If you try running this on 16 gigabytes, it will bottleneck and process words at a painfully slow crawl.
Okay, but if you have that disk space, though, the freedom is wild. Our source downloaded the 8-bit uncensored variant of this model using a free app called LM Studio.
Right.
And because it's uncensored and running locally, it has zero guardrails. He asked it for directions on how to do some highly unsafe things, and the model just provided the instructions. No corporate filter stepping in with a canned, I cannot assist with that message.
It really highlights the double-edged sword of local open source AI. Total autonomy comes with the complete removal of safety nets.
Yeah, and you also inherit all the friction of being your own IT department.
Oh, absolutely.
Our source tried to build a clone of a game called Megabonk. He hooked the local Qwen model up to an agentic harness called Hermes. And for anyone unfamiliar, an agentic harness is a framework that lets the AI act autonomously.
Yeah.
It writes code, checks a task list, evaluates its own work, and writes more code in a loop without human prompting. So he ran it for 2 solid hours on his local GPU.
But the crucial question is whether that local computing time yielded a functional game.
It completely failed.
Yeah.
He hit play and got a blank screen. 2 hours of computing for a broken loop.
Yeah, that happens a lot.
Local agentic loops often get stuck hallucinating errors because they lack the massive parameter count of cloud models to self-correct.
Yeah.
So then he ran a different benchmarking test on the cloud using OpenRouter.
Okay, and how did that compare?
That cloud test took 74 minutes, processed 70,000 tokens, and cost him exactly 25 cents.
Wow.
Right. Local's amazing for privacy and control, but the failure rate makes it incredibly clunky compared to spending a quarter to use a supercomputer.
It does, but that clunkiness is a temporary hurdle. Think about platforms like HyperAgent, which was also highlighted in the sources.
Yeah.
HyperAgent lets you create specialized teams of AI agents that work together.
And the workflow design is brilliant because it's multi-agent and multi-human. You interact with these AI agents exactly like you would interact with human coworkers in a Slack channel.
Right, which is so intuitive.
It is. Our source used it to build a photorealistic B-roll generator. He feeds a video script into the channel, and a team of agents works together to generate motion graphics and visuals. His human team can jump into that same channel and use the workflow without having to rebuild it from scratch.
If we connect this to the bigger picture, this is a monumental shift in how we structure work. We are abandoning the model of renting a brain in the cloud from a tech giant.
Yeah.
We are moving toward owning highly specialized digital employees that live and operate directly on our own machines. Even if the learner isn't building a video game locally today, this matters.
Absolutely.
It means in a couple years, the AI running your business workflows or your smart home won't need an internet connection to function.
And that shift brings up a massive irony in the industry right now. The open source community is speeding up, putting uncensored models directly on our laptops. Meanwhile, the big frontier labs are slamming on the brakes.
Yeah, they really are.
OpenAI just paused reinforcement learning on their next major frontier models, the ones people are calling GPT-6 or Project Astra.
And the stated reason for this pause is due to cybercritical capabilities. Essentially, their safety testing shows these models are becoming too adept at autonomous tasks like hacking websites or breaking out of their digital sandboxes.
Which sounds terrifying until you look at the history.
Yeah.
As our source points out, OpenAI deployed this exact, it's too scary and powerful to release narrative back in 2019 with GPT-2.
Right, I remember that.
And looking back at GPT-2 now, it was basically just a very confident autocomplete. It feels like a marketing tactic masquerading as a safety concern.
Well, whether it's marketing or a legitimate technical plateau, it forces a strategic pivot. Since the big labs can't push raw intelligence forward as fast as they used to, they have to find another way to provide value.
Yeah.
If they can't make the AI significantly smarter, they are making it closer, integrating it deeply into our personal workflows.
Closer is definitely the right word. OpenAI just released a feature for Mac called Computer History. It turns your activity across all your apps and websites into a timeline that ChatGPT can reference.
Okay.
So if you write a project launch update every morning at 9:20 a.m., the AI watches your screen, learns the pattern of apps you open, and offers to turn that exact workflow into a reusable, automated skill for tomorrow.
It is entirely designed to eliminate repetitive tasks by learning your specific habits.
But I have to challenge the premise here, because this sounds incredibly invasive. This functions exactly like that Microsoft recall feature that everybody collectively rebelled against a few months ago.
Oh, the screenshot one.
Yeah, the one that essentially took constant screenshots of everything you did.
Well, functionally, it relies on the same mechanism. You have to explicitly grant it permission, and you can customize which applications it is allowed to monitor, but the core reality remains.
Right.
The AI needs continuous visual access to your screen to help you. And OpenAI is not the only company pushing this deep integration.
Not at all. Apple just introduced a Messages plugin for the ChatGPT Mac app that can search your texts, catch up on group threads, and draft replies in your tone.
Wow.
Claude is now natively integrated into Gmail and can manage your Google Drive files. Meta launched a dedicated Mac app with a massive dock icon to bring their AI natively to your desktop.
It's everywhere.
Perplexity launched Brain, which is a knowledge-based wiki built right into your computer that constantly indexes your files.
Right.
Even Salesforce is bringing agentic coding directly into Slack, where AI and humans write code together in the same chat window.
All of this points to a fundamental redefinition of the operating system. AI is evolving away from being a separate destination like a website you visit to ask a question. It is becoming an invisible layer, sitting on top of your OS, watching your screen, reading your texts, accessing your files, and acting on your behalf before you even prompt it.
But here's where it gets really interesting, though. Because as AI embeds itself onto our local machines, it is also absolutely flooding the wider internet.
Oh, the numbers are crazy.
We have a new Pew Research study in our sources, and the numbers are staggering. If you filter out the old internet meeting pages published before ChatGPT existed, 35% of all web pages published today are generated by AI.
Over a third of the new internet is purely synthetic material. That fundamentally alters how search engines have to evaluate information.
And it's exactly why deep dives like the one we're doing right now are so necessary for the learner. We have to cut through that 35% of AI-generated fluff to find the actual signal, the real human insight.
Yeah.
And it's only going to get harder to tell the difference. Google is now allowing users to remove the visible watermarks on AI-generated images, video, and music.
They are maintaining the invisible synth ID metadata on the backend for tracking, but removing the visual indicators naturally raises immense concerns about discerning reality online for the average user.
And the culture adapting to this synthetic internet is getting bizarre. Like, Alibaba didn't just release that smart local Qwen model.
Right.
They also released a music generation model called Happy Shrimp 1.0.
Happy shrimp.
Happy Shrimp.
What's that?
Our source tested it to make a pop-punk song about the San Diego Padres. It worked, but it sounded incredibly generic. And more importantly, the system flat-out refused to generate music in the specific style of real-world bands. It's imposing its own creative guardrails. Then you look at how OpenAI is quietly policing user behavior. They implemented a new teen version downgrade.
This is a subtle but highly significant form of behavioral policing. It's literally an algorithm judging user maturity.
Right. If you are an adult with a standard account, but you prompt ChatGPT using slang, or you just talk to it playfully like a teenager would, the system might quietly downgrade your account to the restricted teen model. It alters what answers you can get based on its judgment of your chat style. Meanwhile, Google is moving in the opposite direction, giving college students free access to Gemini, advanced specifically to help them with their homework. It is a chaotic patchwork of rules, access, and judgment.
It perfectly reflects a technology that has deeply embedded itself into daily culture before society has agreed on any standardized rules of engagement.
So true. Let's bring this all the way back to the physical world to wrap up. We've talked about AI running natively on our laptops and mapping our biology. The final frontier of this physical shift is putting those offline models into moving bodies.
The robots.
The Unite robot Superman is a physical marvel. It can do a standing jump of 2 meters.
That's crazy.
That's over 6 feet straight up in the air from a standstill. And it runs at a top speed of 12.66 meters per second.
To achieve that level of physical mastery, the software doesn't just learn by falling down in the real world. The mechanism behind that movement relies on reinforcement learning in a virtual physics simulator. The AI controlling the robot simulates millions of jumps and sprints, failing and adjusting its balance parameters countless times before they ever transfer that model into the physical legs of the robot.
And the result is a machine that surpasses human world records for running speed and standing high jumps. If police departments or security firms start deploying autonomous robots that move 12 meters a second, criminals are in serious trouble.
Oh, absolutely.
You are not outrunning a machine that spent 1 million hours practicing in a virtual sandbox. So looking at this massive stack of sources, from 3D wolves and cancer vaccines to uncensored local models and robots that can outrun Usain Bolt. So what does this all mean?
It means we have entered an era of what our source calls marginal little jumps. The earth-shattering loops from the frontier labs are being held back, but the marginal jumps are accumulating rapidly.
Yeah.
AI is no longer a novelty confined to a browser tab. It is quietly embedding itself into our physical health diagnostics. It's living natively on our local computer hardware. It's reading our personal text messages, and it is generating 35% of the new internet. It is the transition from a tool we use to the infrastructure we inhabit.
Which leaves us with one final thing to think about.
Yeah.
I want the learner to really mull this over today.
We know from the sources that 35% of the new internet is already generated by AI. We also know that AI is now being integrated directly into our computer history, watching our screens, writing our code, and drafting our messages locally.
Yeah.
This raises an important question. How long until these local, uncensored AI models aren't even learning from human behavior anymore, but are simply training themselves on the synthetic data generated by all the other AIs living on our machines?
A completely synthetic feedback loop running directly on our own desks.
Yeah.
I love that thought. Thank you so much for joining us for today's deep dive. Keep questioning the information around you, and we'll see you next time.